Hi there. In this video, we're going to solve for x in a quartic polynomial by factoring, okay? So we're going to go through the whole process, factor this completely, and then solve for x. So this is a long question, and the video might be quite a long time. Please keep in mind that this is a quartic, so when we get as we keep getting factors, it will decrease in size and it will get easier and easier for us. So let's go through the first step here. So the first step we need to do first is to guess factors of the constant term. So we want to guess factors of this. And we want to evaluate a polynomial. So I will, instead of writing it 0 is equal to the polynomial, why don't I write it as using a function notation. So if I call it p of x, okay? And you could say that on your assignment, right? Let p of x equal to this polynomial. Okay, that gives us some notation, that gives us some power here. So I'm going to guess the factors of 8 as values for x, okay? And these, hopefully, one of them will work for us. I do notice I have a leading coefficient of 2, which means that one of them might not work for us, but I think it's likely that one will, okay? So the factors of 8, they are plus minus 1, plus minus 2, plus minus 4, and plus minus 8. Okay, so these are all the numbers. There are 8 different possibilities that we could guess. Okay, I'm just going to start going up the list. I'll start with 1 and I'll keep going. Okay, the reason I start with 1, then that's because if I start with 1, then I already I know that 1 to the power 4 is pretty easy to solve, right? So it's not too bad on the math. So I want to start with some of the easier ones and get them out of the way. That can sometimes be kind of speedy, um, but it could be that maybe one of my factors is plus 8, okay, or minus 8, and that wouldn't be good. So for this technique, so you might want to start from the other end, but largely it doesn't matter as long as you get through your list. As soon as you're able to find an x value, you want to stop. Okay, you do not need to go any further. Stop with that and start your polynomial long division. Okay. So here's what we're going to go with. So I will guess, I will make a table here of guesses, okay? So my guess is x equal to 1, positive 1, okay? Seems like a good place to start, okay? And then p of x, okay? So I'm basically making a table of values here, right? So let me just double check. So all of this in green I may erase if it doesn't work out for us. So I am substituting in 1, right? I'm evaluating my polynomial at 1. So I have to substitute in all of the ones here in brackets. Okay. So 1 to the power 4, that's 1. This is why it's easy. So I just get 2 there. 1 to the power 3, that is 1. So I just get 13. Again, I just get 24. I just get minus 1. And then I have plus 8. So let's see. If this is 0, then I have correctly guessed a value for my first factor. Okay? So 2 minus 13, what is that? That's negative 11. Minus 24, minus 1, plus 8. Okay, well, minus 1 and minus 11, that is minus 12. Minus 24, plus 8. And minus 12 minus 24, well, that is negative 36 plus 8. This is not 0, so I can stop there, okay? And maybe you could see that earlier. Maybe you could see at this step right here that it's not going to be 0, so then you stop, okay? You want to get pretty quick at evaluating polynomials, okay? So I plugged in 1, and 0 did not come out, which means that this is not 0, so I will move on. I will erase all of this and move on to my next guess. So my next guess is going to be, I don't know, negative 1, okay? I just tried positive 1, and actually instead of erasing this, I should have just written in a negative, but that's fine. I can show you again how we evaluate, okay? So we evaluate by substituting in negative 1, okay? Negative 1 here, minus 24 times negative 1 to the power of 2 minus negative 1 plus 8, okay? Well, negative 1 to the power of 4, that is 1, so I have 2. Negative 1 to the power of 3, that is negative 1. So I have negative 1 times negative 13, that is positive 13. Negative 24 times 1, that is negative 24. Minus 1, that is the same as plus 1, plus 8, okay? And I'm just going to add my positives together. So I see here I have 15, right? Then I have plus 1, plus 8, minus 24, okay? And then 15 plus 1, that's 16. 16 plus 8, this is looking good because 16 plus 8 is 24, and we get 24 minus 24, okay? And that is 0. So in other words, my guess x equals negative 1, that is a good guess, okay? So I need to start factoring my polynomial based on my guess of negative 1. So I will now write the factor that this polynomial is divisible by. Okay? So I know that this polynomial can be divided by x minus my guess. Okay? So my guess is negative 1, so I go x minus minus 1, right? Well, minus 1, that's the same as plus 1. So I know that this polynomial above can be divided by x plus 1. So I am going to rewrite this polynomial out here. 2x to the power 4 minus 13x cubed minus 24x squared minus x plus 8. Okay? So notice I just gave up on my guessing here, okay? I'm done with guessing for now. I have figured out a factor, so I'm going to go ahead and push forward, okay? As soon as we have a factor, push forward with the polynomial long division. Okay, so I have this. Let's now find the long division. So I will multiply, looks like I'll multiply by 2x to the power of 3. Okay, let me write this in green actually. 2x to the power of 3. Okay, if I do that, then when I multiply 2x to the power of 3 times x plus 1, I get 2x to the power of 4, which is what I wanted, right? So that things will subtract and disappear, and I get plus 2x to the power of 3 here. I subtract this, which means I get 0, and I will have negative 13 minus 2. Well, that is negative 15x cubed. Okay? I will bring down my next piece, my next term, and now I have to figure out again what I multiply by. So I multiply by the looks of it, negative 15x to the power of 2. Okay? If I do that, then I get to negative 15x to the power of 3 here, because when I multiply them back through, I will get this nice and it will cancel, but I also get the negative 15x squared there. And if I subtract these, let's see what we get. So I will get 0 on this side, but then I will get negative 24 plus 15. So let's see, what is that? That's plus 10. That is 14, and then plus 5 is 9. So it looks like I'm getting negative 9x squared. Okay? I will bring down my negative x. Okay? And now I keep going. So I have to scroll down here. I need to multiply by the looks of it, negative 9x. Okay? So I'll put negative 9x here. If I do that, I get negative 9x squared. Okay? And negative 9x. If I subtract these, then I will get 0, and I will get plus 9, so that should be plus 9 minus 1, which is 8x. Okay, and I bring this down. We're looking good, okay, because if you notice here, then I need to multiply by positive 8, okay, and that means I will have 8x plus 8, which means I have a remainder of 0, which is good. That means that these two polynomials can be multiplied together. So I'm going to copy and paste these polynomials, okay, for us down here. Very quickly, come on, there we go. So that big p of x at the beginning, it has now become two different polynomials. These are the polynomials, okay? They are x plus 1 times 2x to the power of 3 minus 15x to the power of 2 minus 9x plus 8, okay? And now we start the process all over again, but with this green polynomial here. So I'm going to write p with a little subscript here, 1, okay? p1 of x. And I'm going to say let p1 of x equal 2x to the power of 3 minus 15x squared minus 9x plus 8, okay? And it essentially becomes the same problem we just had, except with a smaller degree, okay? So now we have only a cubic. So I've already figured out one of the factors. I will now reduce this cubic down, okay? We'll find out another factor for us. Okay, so again, we have to think about factors of 8. Well, I know the factors of 8 are plus minus 1, plus minus 2, plus minus 4, and plus minus 8, okay? Well, last time we had a negative 1 as a factor. You know, I'm starting with the 1s anyways. Why don't I start with negative 1? There's a chance that it will be another factor. Maybe it will be, maybe it won't be, okay? So why don't I just try negative 1 again and see what happens. So if I substitute in x equals negative 1, what will I get for p1 of x, okay? Will it be 0 or will it be non-zero? If it is 0, then I'm good. I can use this. Okay, so p1 of negative 1. That's what I'm substituting in. And we have here 2 times negative 1 to the power of 3. Okay, and I keep substituting in brackets. And now I will evaluate. So negative 1 to the power of 3 is negative 1. So I have negative 2 here, minus 15, because this is a positive 1. Negative 9 times negative 1 is positive 9, and then plus 18. So let's see what we have here. So if I add my negatives together, they are negative 17, and look at this, I have positive 17 as well, okay? So in other words, this is 0. I stop here, okay? So this is 0, which means this is another one, okay? So we have a factor which occurs twice. This means that the factor x plus 1, right? That's what we just divided by. The factor x plus 1 has multiplicity 2. Okay, it occurs twice in our factorization. So I will now divide by x plus 1 again. Remember, it's x minus your guess. So I guessed negative 1, so minus 1, that gets me x plus 1. Okay, I will, again, rewrite out this. So we have it. Squared minus 9x plus 8. And here I go again, long dividing, okay? We were lucky. I got this second guess right away, maybe by trying the same, since the same factor appeared again. I just tried it again, and it seemed to work, okay? That might be a shortcut for some questions on an assignment or a test, but in general, if you're just trying to factor any polynomial, it might be that you have to go all the way up to 8 to guess, okay? So it would be good and maybe efficient if you made a table of values for this polynomial. And then you would be able to come out with factors a little quicker if you have to go this far along, okay? Always start with a 1 though, okay? And start with the lowest, I would suggest, because usually that math is a bit easier to do in your head and you can kind of do it quicker. You don't have to resort to a calculator. Okay, I will get back to the long dividing. So if I long divide these two polynomials now, I have x plus 1, so I need to multiply by the looks of it, 2x to the power of 2. So 2x to the power of 2. If I do that, I will get 2x to the power of 3 plus 2x to the power of 2. Subtracting these, I will get 0 here. And I'm subtracting 2x squared, so I will get negative 17x squared. I will bring down my negative 9x, and I will take another guess at, or pardon me, figure out what I need to multiply by to get negative 17x squared. So that should be negative 17x, okay, which gives me negative 17x squared. When I multiply it by x, when I multiply that by the 1, I get negative 17x, okay? If I subtract these, I get 0 in the first term, and in the second term, I'm adding 17 now, so 17 minus 9, what is that? That should be 8x. Oh, this is a good thing to get, as we know from last time. It means that we have plus 8 here. Then when we multiply by 8, we will get a remainder of 0. As you go on, okay, it gets easier because you have fewer terms to divide through, okay? So we're only in a cubic now, so we have fewer terms. We don't have to go through the long division algorithm for as long. So I will copy and paste these two polynomials now for us. Now I had the same factor twice, so why don't I just paste it twice so that I know that my original p of x, okay, my original p of x is now equal, hold on here, is equal to this, okay? So my original p of x, not p1 of x, but the original p of x, that's equal to this whole thing, okay? I've factored twice. Now what we have left is a quadratic, okay? So notice I have this leading coefficient. So this is why we always guess the factors of the trailing coefficient, or the constant term first, because we can get out some simpler ones, and then we boil our way down to a quadratic. Now with a quadratic, we can factor this in a couple different ways. We could use that strategy of guessing an x value again if we wanted to, but actually we know how to factor quadratic expressions fairly well, okay, at this point. So I am going to make a guess, okay, at that. I'm going to try to factor this into two brackets, okay? So to do that, I need to come out with the factors of the leading coefficient and the constant term, and put them in a table. Okay, so the factors of 2, they are 1 and 2. Not a lot of choice. Factors of 8, as we know from earlier, they are 1 and 8. Now I'm going to write them in their pairs, right? 1 times 8 is 8, and 2 times 4 is 8, okay? Now I have to figure out some sort of combination that will get this to work. So I know I need to somehow get to negative 17x. So I want to find some sort of combination that is going to get me to negative 17. Well, 2 times 2 gets me to 4, and 1 times 4 gets me to 8. So plus minus, or 1 times 4 gives me 4. So 4 plus or minus 4, that's 0. That's not going to work out for me. Okay. What about 1 times, or 2 times 1 and 1 times 8? Well, that is, by the looks of it, 8 plus or minus 2. That's not going to work out for me either. However, I do notice that 2 times 8 is 16. That's getting closer, okay? 16, and 1 times 1 is 1. So this seems like it would be the appropriate strategy, right? So if I have 16, when I get 2 times 8, okay, and then I have 1 when I get 1 times 1, I know that I need to have a negative, and I need to subtract both in order to get negative 17, right? So that's my strategy. So I'm just trying different combinations in order to get to that negative 17. So if I do that, I notice I need a negative 16 and I need a negative 1. Well, my leading coefficient is a positive 2. So why don't I write out 2 and, well, the 1 here, but I'm just going to write x. So 2x and 1x, okay? Those will multiply together to get me my 2x, my positive 2x. And then the other two factors could be negative. So I know they both need to be negative because these are already positive, okay? And if this is positive and that's positive, then I know I need -8 and -1 here. So moving on, I figure out I need to multiply 2 times -8, which means -8 has to go in this bracket. Okay? And then that means that the -1 has to go in this bracket. Okay? Which means I have finally factored this completely, and I can go back to the original question, which was solve for x. So I have here the completely factored polynomial. Okay? So from this step, basically, we're back to our original question, which was solve for x. Now we have already factored, so we've done all of the hard work, and the difficultness of this problem is gone. Okay, I don't want you to think of this as being difficult, this solving for x. Okay, so we have 4 factors here, which result in 4 linear equations. Now, the thing about the multiplicity, okay, these x plus 1s, they become one, essentially one solution, okay? So we only have to solve this one. So I can say 0 is equal to x plus 1. But that only works if I have multiplicity more than 1. With the other factors, I only have a multiplicity of 1. So I should have 0 is equal to 2x minus 1. And here I will have 0 is equal to x minus 8. So then it's a matter of solving all 3 of these, okay? So I bring the 1 over, so then I get x is equal to -1. That's it, okay? Bring the -1 over here, that's 1 is equal to 2x. I divide by the 2, and then it should give me x is equal to 1/2, okay? And here I bring the 8 over, and I get x is equal to 8, okay? This should be a good strategy to completely factor. So we'll just go over all of our work again. All right, if you completely factor, you should be able to get down to ideally to a quadratic. Once you have that quadratic, you should be able to factor that quadratic quickly, okay, rather than by guessing more factors. So at most, you should have to make 2 correct guesses at the factors of your large quartic polynomial, okay, because we only cover up to quartic polynomials in this course, okay. If you have a cubic polynomial, you only have to make 1 correct guess before you're at a quadratic, okay. So that is your full solution. So I have now my 3 solutions for x, okay? And that's the end of this video. Thanks.